Hello friends, hope you're doing well. Welcome to the 8th episode of the geometry series. In this session, we are going to take up a few typical practice questions which we can expect in the digital SAT format. Okay, so let's get going here. First question. So we have a triangle PTU and we have these horizontal lines like VQ and WR such that VQ is parallel to WR and is parallel to ST. So essentially we have these three horizontal lines which are parallel to the third line TU. Okay, the length of PS is 15, so this length is 15, and we have to find the length of RS, right? And on this side of the triangle, these lengths are given, so PV is equal to x minus 1, VW is equal to x plus 1, and WQ is equal to x, correct? So this is the situation and we have to find the length of RS, correct? So the fact that these lines are parallel, right? The triangle proportionality theorem is the one which comes to mind immediately, right? And what does that theorem say? That theorem says that whenever you have a line parallel to another line of the triangle and it cuts the other two sides of the triangle, then these portions are in the same ratio. So essentially, if we look at this triangle for a moment, right? So what we are saying is that PW over WT is equal to PR over RS, correct? Because this line WR is parallel to ST and hence it will bisect, it will intersect the other two sides in the same ratio. So essentially, we are saying that PW over WT is equal to PR over RS, correct? This is nothing but the triangle proportionality theorem, right? Now we see on this side, PW is what? X minus 1 plus X plus 1. So PW is like 2X. WT is already given as X is equal to PR over RS, correct? X and X cancel out. So essentially we are saying that PR is equal to twice of RS, right? And we have been given that PS is 15. So if the whole length is 15 and this portion is twice of this, then obviously this portion is going to be 10 and this is going to be 5. So in other words, RS is equal to 5. Again, just to reiterate, right? At the first look, this question looks a bit messy, but when we really look into that a little more closely, we see that these lines are parallel, right? All these lines are parallel of this triangle PTS, and hence we use the triangle proportionality theorem, which says that this portion PW over WT will be equal to PR over RS, right? And PW over WT comes out to be as 2:1. Hence, PR over RS will be 2:1, or PR will be twice of RS. The length of the entire PS is given as 15, and hence RS would be 5 and PR would be 10. Question number 2. So we have an equilateral triangle ABC, okay, and the area of the triangle, equilateral triangle, is given out to be as 25 root 3, okay, and then each side of this triangle is, let's say, A, and then there are these three squares. I mean, don't go by the picture. They are not looking as squares, but yes. So 1, 2, 3. These are the three squares, and we have to find the area of all of these squares. Correct. So essentially, we got to find A, right, which is the side of each square. So then we can find the area of each of the squares and add them, right? The area of the triangle is given as 25 root 3. Now we know that the area of an equilateral triangle in terms of its sides is given by root 3 by 4A square. Okay, so the point I'm trying to make is that if you have an equilateral triangle with side A, let's say, right, So the area of the triangle is root 3 over 4a square. Okay, you can use this ready-made thing. I mean, you can always prove this. You can always draw a perpendicular here, and then it will bisect this side into two equal parts, and you can use the Pythagoras theorem to find the height and all of that stuff, and then you can find the area of this triangle as half times base times height. But when you will do all of that stuff, you will finally get down to this. So this is important, and you can use this as a kind of a cheeky trick, right, in terms of the equilateral triangles. Okay, so the question becomes as simple as that root 3 over 4a square is equal to 25 root 3, which will directly give you the value of a. Let's see. So root 3 over 4a square is equal to 25 root 3, right, which gives you a is equal to root 3 cancels out, a square is equal to 100 and a is equal to 10. I mean, you will get a equal to minus 10 also, which you can discard because there is no meaning of the thing that the side of the equilateral triangle cannot be negative, right? So a equal to 10 basically when we use this. As soon as we know a equal to 10, the area of each of these squares is going to be 10 times 10, which is 100. So this is going to be 100, this is going to be 100, and this is going to be 100. So the area of all the three squares are going to be nothing but 300. Right? Again, just to quickly reiterate, right, we are using the fact that the area of an equilateral triangle in terms of its side is root 3 over 4 side square, and that is given out to be 25 root 3, which directly gives us the value of a. In fact, it gives us the value of a square, which is what we actually needed, because the area of a square is a square. We didn't even have to do the square root, right? Because this directly gives us the area of one square. A square is equal to 100, so obviously 3 times 100, so 300. Next question. So we have this combination of two triangles, or we have this figure ABCD, which is nothing but a combination of two right triangles, ABC and ACD. With these given sides, AD is 12, AB is 11, and BC is 4 root 3, and we have to find the area of this entire figure, correct? So obviously what we can do is find the area of this triangle, find the area of this triangle, and add both of them up, correct? Now, as far as the area of the triangle ABC is concerned, you know, this angle is 90 degrees, so we can consider this as the base and this is the height. So the area of triangle ABC, we can directly right away get as half times 11 times 4 root 3, right? Half times base times height, kind of. So it is 22 root 3. So the area of triangle ABC is 22 root 3. Now for finding the area of triangle ACD, we got to find this height. Okay, we can use Pythagoras theorem on the first triangle to get this side, and then we can again use Pythagoras theorem on the lower triangle to get the CD, right? Now when we apply Pythagoras theorem on the first triangle ABC, we get square of 11 plus square of 4 root 3, right, is equal to AC square. Hence this gives us AC square is equal to 169, or AC is equal to 13, correct? So this side is 13, which is nothing but the hypotenuse of the lower triangle as well. We can again use Pythagoras theorem here to get the value of CD, and this comes out to be as 5, right? So the area of ACD is nothing but half times 12 times 5, which is 30. So the total area of the entire figure is 30 plus 22 root 3, right? So again, pretty straightforward, right? We had the base and the height for the above triangle, we directly found the area, and then we used the Pythagoras theorem on the above triangle to find this side AC as 13. We again use Pythagoras theorem on the lower triangle to find this CD as 5, and then we did area of ACD is half times base times height, which came out to be 30. Hence the area of the total figure is 30 plus 22 root 3. Question number 4. So we have two circles here. The bigger circle with the center A and the smaller circle with center B. So we two circles, but they are not concentric. They have different centers. And we have this line which is like a tangent to the smaller circle, and the length of this line segment is 24. And with this given information, we have to find the area of the shaded portion. Okay. Okay. So what is the area of the shaded portion? The area of the shaded portion is nothing but the area of this semicircle minus the area of this semicircle. Correct? I mean, these are circles and this is a semicircle, right? Because it's passing through the center, so this is the diameter, right? This serves as the diameter of the smaller circle as well and of the bigger circle as well. So let's say that the radius of the bigger circle is r and the radius of the smaller circle is, let's say, small r. So essentially what we are trying to find is pi r square over 2 minus pi r square over 2. Correct? Because pi r square over 2 is the area of this bigger semicircle, and pi r square over 2 is the area of this smaller semicircle. So this is what essentially we have to find when they are saying area of the shaded portion. Correct? Now pi over 2 is common, r square minus r square. Correct? So essentially we are looking for this. If we can somehow get our hand around on this expression or get the value of this piece, then we are done. Now let's look at a few things here, right? So A is the center of the bigger circle. So let's say if we join this point with the center, so this will be nothing but capital R, right? Because this is the center of the bigger circle, so this will be the radius of the bigger circle, which is like R. Okay, and now this line segment AB, let's say we call it as PQ, right? This line segment is nothing but a chord, right? It serves as a chord for the bigger circle, and we know that when we draw a perpendicular from the center to the chord, it bisects the chord into two equal parts. So if we drop a perpendicular from the center to this chord, right, it will bisect the chord into two equal parts. That's the chord property, right? So this guy becomes 12 and this guy becomes 12. Correct? So I'm trying to concentrate on this triangle here. Correct? So this is capital R and this is a right angle triangle because we drew a perpendicular from the center to the chord. So this is 90 degrees. And this side is 12 because it's half of 24. Now if we look at this is the center of the smaller circle and this is the tangent for the smaller circle. And when we know that when we join the center to the point of contact of the tangent, it is 90 degrees to the tangent. So when we join this point center with this point on the tangent, it will be 90 degrees. Correct? And this is nothing but small r. Right? Now if we look at this is like a rectangle because these two lines are perpendicular to the same line. So this length is r, so this will also be small r. Right? Now it becomes very simple. You just look at the Pythagoras theorem for this triangle and we say that r square is equal to 12 square, which is 144, plus r square. Right? Or in other words, r square minus r square is equal to 144. And this is what we were looking for. So we just put in this value here and we get pi over 2 times 144, which is 72 pi. So 72 pi is the area of the shaded portion. Again, just to reiterate, right, it's a little involved question, but yes, we are using a couple of things here, right? First of all, we are using the property that when we are drawing a perpendicular from the center to a chord, it bisects the chord, right? So this is 12 and this is 12, right? And then we are using the property that when we are joining the center to the tangent point, it's 90 degrees. So this point to this point would be 90 degrees. This is 90 degree to the same line, these both these lines, and if this is R, right, the small radius, this will also be R. And then we are looking at this triangle and use the Pythagoras theorem to get the value of this expression, which comes out to be 72 pi. Okay, let's take one last question here. ABCD is a rectangle with this side AB as 40, side BC at 16, right? And then within that rectangle, there is a square BCFE. This is a square wherein obviously these sides are equal, 16, 16, 16 and 16, okay? And from this corner A, there is a 45 degree line segment which is drawn, which cuts this side at G, okay? And we have to find the area of this shaded portion, AEFG, correct? Now clearly AEFG is a trapezoid, correct? And the area of a trapezoid is the sum of the bases, the parallel bases, times height divided by 2. So this is 16 and hence this is also 16. Obviously this is in square. So AE will be 40 minus 16, right? Which is equal to 24. So AE is 24 plus the other base. So this base plus this base. Let's say this is X, right? Times the height, which is 16, divided by 2. So all we got to do is to somehow find the value of X, correct? And then we can find the area of this shaded portion. Now this, if you look at this right triangle, this is 45 degrees, right? If this is 45 degrees, obviously this is also 45 degrees, correct? And this side is the same as this, obviously it's a rectangle. So in a 45-45 triangle, obviously it becomes an isosceles triangle as well. So if this is 16, then this is also 16. So DG is 16 because this angle is 45 degrees. Now we already found the length of AE, which was 24, which is the same as DF. So DF minus DG, so 24 minus 16 will give us X, right? So X is nothing but 24 minus 16. This 24 minus 16, which comes out to be as 8. We'll just plug this value here and we get 24 plus 8 times 16 divided by 2. 2 times 8 is 16, 24 plus 8 is 32. 32 times 8 is 256. So the area of the shaded portion is 256. Again, just to quickly reiterate, we see that AEFG is a trapezoid, right? We have the length of this base, we have the height between the two bases, the two parallel bases. All we got to do is to find was this base, which we could do because this angle was given as 45 degrees. We found the value of this side X. Area of the trapezoid is sum of the bases times height divided by 2, and we get 256. Hey friends, hope you liked the video and you found the examples meaningful and useful. Keep practicing. In case of any questions, please feel free to reach out to us. Do like and subscribe. See you in the next session.